All right, what I want to do right now is to try to demonstrate a couple of these gyroscopic ideas in a slightly different way, because the more ways you have to look at it, the better. And so Mark is going to help me by revving this thing up faster than I could ever hope to turn it by myself. Okay, this thing is really moving now. Notice, with it moving this fast, how low the precessional period is. Look at how slowly it's moving. That's because the omega value is so high. Remember before it was turning much more quickly, round and round in a circle. And depending on which way I pivot, this changes the direction of the torque from turning precession in one direction to the other. Okay, now, if you didn't understand that last explanation, think about this. If I try to turn it sideways like this, that turns me this way. If I try to turn it sideways like this, it turns me that way. But isn't that exactly what was happening when we let the gyroscope go and let the torque act on the wheel? Except the difference here is that I'm holding the wheel solid, and so what has to turn is me. So I turn. Instead of the gyroscope turning this way, it's me that turns. Now, Mrs. Cobb is going to show us a smaller gyroscope. And so let's take a look at how this one works. And here we're going to keep the gyroscope so that its rotational, or its angular momentum vector, is pointed closer to the vertical. Go ahead.
So here we have our standard gyroscope. Instead of using string, we're going to use the easier method.
Okay, so now we'll notice we have a precessional frequency, but as the dissipative force is lower omega, notice the precessional frequency is getting larger. Also, the component of angular momentum in the vertical direction is getting lower as the disk's rotational velocity decreases, and so it tries to compensate, conserve angular momentum by sweeping around faster to give it a larger, or at least the same value of angular momentum that it had in the vertical direction to begin with. So as this thing turns, it goes faster and faster until finally the gravity forces win out, which is what will eventually always happen, is that this thing will stop turning, and then it'll go back to what our normal common sense intuition will tell us.